Most of the pteridophytes produce one spore, which are known as homospores, and the phenomenon is known as homospory. However, some pteridophytes produce two different types of spores, which are differing in their size, structure, and function. Such pteridophytes are known as heterospores, and the phenomenon is known as heterospory. There are two types of spores. They are megaspores and microspores. Microspores are smaller in size, while megaspores are larger in size. Origin of heterospory. The origin of heterospory can be better discussed based on their evidences from paleobotany, developmental, and experimental studies. Paleobotanical studies. It has been suggested that heterospory arose due to the degeneration of some spores in a few sporangia. As more nutrition becomes available to less number of spores, the surviving spore grow better, hence increase in their size. Evidences from developmental studies. In heterosporous pteridophytes, the development of micro and megasporangia follow the same pattern. They have identical organization but for their size. While in megasporangia, most of the spore mother cells degenerate, but in microsporangia, only a few mother cells are disorganized. The phenomenon of heterospory becomes distinct either before or after meiosis. Some pteridophytes like Marsilea, Salvia, and Azolla, the phenomenon of heterospory becomes distinct after meiosis. Like in Marsilea, 64 microspores and 64 megaspores are formed after meiosis in microsporangium and in megasporangium respectively. In microsporangium, all the microscopes are functional, while in megasporangium, only one megaspore is functional and rest degenerates. Evidences from experimental studies. Experimental studies on Selaginella and Marsilea suggest that nutritional factors mainly govern the heterospory. Under the conditions of low light intensity, the photosynthetic activity of Selaginella was retarded and it produced microsporangia. By sudden lowering of the temperature, the size of the microspore in the sporocarp of Marsilea increases by 6 times. Seed habit. The adoption of heterospory and the retention and the germination of a single megaspore within the megasporangium to form a single gametophyte leads to the phenomenon of seed habit, which is a characteristic feature of the spermatophytes. Origin of seed habit. The origin of seed habit is treated with the following: production of two types of spores, reduction in the number of megaspores, retention and germination of megaspores, and the fertilization of the egg. Selaginella approaches towards seed habit because of the following features: the occurrence of the phenomenon of heterospory, germination of megaspore inside the megasporangium, retention of megaspore inside megasporangium either till the formation of female gametophyte or even after fertilization. Development of only one megaspore per megasporangium. For example, in Selaginella monospora,